Hello, how you doing? It's Mr. Do the Math, and today we're going to talk about angle side theorem, right? We kind of talked about it yesterday. But angle side theorem is basically revolved around this triangle. What is that? Isosceles triangle. And so the angle side theorem basically says that if the sides are congruent, then the angles are congruent, right? That's theorem 20. Theorem 21 is if the angles are congruent, then sides are congruent, right? And then so then we kind of talked about it. Let's talk about it now. A triangle that has no congruent sides is called a what?
Scalene.
It's a scalene triangle. Scalene. Scalene is the Greek god of, what did I say? Greek god of.
No, isosceles.
Isosceles is the Greek
He's
god.
not a Greek god. He's a Greek.
Scalene is the lady that works. She works at a pie shop. Right. We're giving identities to these triangles. All right. So, anyways, basically, there's a correlation between the side length and the angle size, right? So, on the longer side, the larger side is opposite the larger angle. That's the big angle. That's the biggest angle. And then the shorter side is across from the smallest angle. That's the smallest. EST, smallest angle. All right, cool. All right, so that's just the side. That's a side note. Okay. Now, what we're gonna do now is we're gonna look at two proofs. We're gonna look at two common proofs that we use or we do for side angle theorem. So we're gonna look at this triangle here. I think we kind of looked at it yesterday, but let's look at it again. So we got this triangle. We get W, X, Y, Z, A, T, B. This is 3, and this is 4. All right. Remember, I always say, like, with our proofs, we want to find what's given, and then we want to identify the given parts, and then we're going to have to, in this sense, we're going to have to create two congruent. We have to create two congruent triangles before we can get to the angles. So here we go. They said angle 3 is congruent to angle 4, right? They also said segment BX is congruent to segment AY, and they said BW, the West, is congruent to Arizona. Those are the givens. All right. So let's mark that off in our picture. Those are congruent. These are congruent, and these are congruent. Okay. So looking at that, what two triangles do we have to prove congruent? Yes, Mr. Goodrow.
Triangle AZY and triangle BWX.
These two, right? These two triangles. All right. So now, based on the information, what's the next thing we need to do? So we got two sides congruent. Right? What do you think we can do? Are these gonna be congruent by side, or side angle side?
Side angle side.
Side angle side. How are we gonna make the angle congruent? All right, what's the relationship between angle 3 and angle B? They're supplementary, right? They're supplementary. So that's what we need to say. So angle 3 is supplementary to, oh no, we can't do that first. First thing we need to do is we need to say we got a straight angle, right? Got a straight angle. Where's the straight angle?
WBT.
WBT, angle WBT is straight, right? How so?
Assume from diagram.
Yeah, assume, right? All right. Do we see another situation like it? Well, let's deal with him. So then we can say angle 3 is supplementary to angle
B.
WBX, right? Angle B, WBX, right? Why? Two angles equal 180 degrees, then it's supplementary, right? Definition of supplementary angles, right? Then we have another pair of supplementary straight angles. Where's the straight angle right here? TAZ. Angle TAZ equals 180 degrees, right? Why? Assumed from diagram. And then, so we can say angle 4 is supplementary to angle ZAY, Z, right? Why? Because same as this one. So two angles equal 180 degrees, then they're supplementary. Right? Definition of supplementary angles. All right, so cool. Now we got two supplementary angles. Bop, 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 bop. They said 3 and 4 are congruent. So what theorem is that to prove that these two are congruent? Theorem 5. What does theorem 5 say? Angles are supplementary to congruent angles, then they're congruent, right? So this, and abbreviated is congruent supplement. So angle WBX is congruent to angle ZAY, right? They're congruent supplements. You can write that down. Congruent supplements. All right, so now we got this. All right, we need more space, so we're gonna continue over here. All right, so then we can say those two triangles are congruent. Why?
Side angle side.
Side angle side, right? Now, because these are congruent based on side angle side, we can say that these two are congruent. Angle W is congruent to angle Z. Why?
CPCTC.
CPCTC. Corresponding parts of congruent triangles are congruent. Alright? And they wanted us to prove that this big triangle is isosceles. Right? So, do we have enough information to prove that it's isosceles? Yeah. So we can say the triangle is isosceles. Why? Yeah.
If two or more angles are congruent, then it's isosceles.
Very good. Alright, so you're going to see something like that on your test. Alright? Let's look at another one. So you got this triangle here. So you got this, you got a triangle that's going to look like this, and you got one that's going to look like this. Okay? For this particular triangle, let's label it E, F, G, H, D. Alright? It's the given information. They said angle E is congruent to angle H. Right? They said segment EF is congruent to segment GH. So EF is congruent to GH. That's congruent as well. Right? They want you to prove that, you got to prove that DF is congruent to DG. DF is congruent to DG. Okay? Alright? This is given. Bop, bop. What's the next thing we can say? Remember what our new rules were, right? If angles are congruent, the segments are congruent, right? So what can you say about this? D is congruent to who? HD. High definition. Alright, why? Definition of isosceles, right? Or basically saying if angles are congruent, two angles are congruent, then it's opposite sides are congruent. Can you see this end?
Yeah.
Okay, cool. So now we got this, bop, bop. Then what? Yes, sir.
Triangle congruent to triangle.
Exactly. This triangle is congruent. So EDF is congruent to triangle
HDG.
HDG, right? So why?
Side.
Side angle side again, right? Side angle side. Finally, can we say this now?
Yeah.
Yeah, so we can say DF is congruent to DG por K. CPCTC. All right, so again, with these situations, you got first thing you want to do is identify your givens. Mark your givens, right? Mark your givens, right? 2. The next thing you want to do is you want to prove triangles congruent, right? Prove the triangles congruent. Then 3, find whatever your proof is. Find whatever your proof is, right? Because once you find your triangles congruent, then everything else takes care of itself, right? You want to mark your givens, prove triangles congruent. So you cannot do CPCTC until triangles are congruent, all right? Then you figure out what your proof is, okay? Feel a little bit better seeing it the second day? Yeah? Okay. So, got any more questions, comment below. Don't forget to like and subscribe. Let's do the math.